Okay, Algebra 2 kiddos. Um, Moving on to section 7.2. Again, want to reiterate that these are voluntary. Okay, this is new material, but I know sequences and series and stuff comes up on the ACT test, and it will probably be beneficial to those of you moving on to college algebra or trig. So anyway, we're moving on, but this is totally voluntary. Assignments aren't graded. So just want to make sure everyone's aware of that. Okay, 7.2 study guide. We're talking about an arithmetic sequence. Now, believe it or not, that's how it's pronounced, even though it looks like arithmetic. Okay, we talked about some sequences and series last time in section 7.1, but we didn't really have a hard and fast rule. We just kind of had to play around until we found kind of the rule for each one of them. Well, today it's a little different. I like today better actually, because now we get a hard and fast rule. So there's all different kinds of sequences. There's geometric sequences, we'll get to those, and there's arithmetic sequences. An arithmetic sequence, the difference of consecutive terms is constant. That's the important part. The distance of, or the difference of consecutive terms is constant. So the common difference is denoted by the letter D, okay? So for instance, if you have the sequence 1, 3, 5, 7, you'll notice that the common difference here is +2. You add 2 to get from one term to the next. So our D would be a +2 in that case. That's what they're talking about. Now, if you're trying to write the rule, okay, for these, this is the formula to find the rule for the nth term of an arithmetic sequence. So again, we tried that last time with 7.1 and it was just kind of a shot in the dark. We had to kind of play with it. So this one tells us that a sub n, so the nth term of some sequence, equals the first term plus n minus 1. So again, if we're looking for the 10th term, then the n would be 10, 10 minus 1 times d. D is that difference, that common difference. So in this case, if I'm trying to find the rule for this one that I put up here, I'll just use this as an example, okay? If I try to find the rule here, if I use my formula, this is going to be a sub n equals my a1. Remember, this is my a sub 1. It's my first term. Okay, that's what a sub 1 means, is the first term. So a sub n equals 1 plus n minus 1 times d. Well, my d for the sequence right above there is a 2. That's what we'd already found. So then this 2, if I distribute, okay, I'm going to have 2n minus 2, right? And then plus 1. So my a sub n, now I usually write these backwards than the book, but it does not matter. I would put 2n minus 1. Now, the way the book key lists it is a sub n equals -1 plus 2n. It doesn't matter. Obviously, you all know that addition is commutative. Okay, it doesn't really matter what order we put the terms in as long as the signs stay on the right term. So 2n minus 1 or -1 plus 2n. That's what we're talking about. That's where we use the formula. That's how it's applied. Okay. So again, this I want to point out, this is the a sub 1. Okay, this is your d in your formula. Okay, now we talked last time about sequences, you know, just being repetitive numbers in some kind of pattern. An arithmetic series, if you remember when we talked about series, we talked about summation of series. Okay, so the sum is where you add up. So we had that sigma notation, if you remember that from the series. So for this one, arithmetic series, this is our formula for the sum of n terms. So if we were trying to add up the first 10 terms of a sequence, we would get this series, okay? And this would be S sub n. So the sum of 10 terms, say, if my n was 10, equals 10 times the first term plus the 10th term divided by 2. Okay, so for instance, let's use my little example that I have right up there again and find the sum. So let's find the sum of, let's just do the first 4 terms. Okay, according to the formula, this would be 4 times the first term is my 1, the fourth term is my 7, and then we divide by 2. Okay, so 8 divided by 2 is 4, 4 times 4 is 16. So this is the sum of the first 4 terms of my sequence that I have there in red up above. And we could test that, right? We could actually get out a handy dandy calculator or use our noggins. And 1 plus 3 plus 5 plus 7. 1 plus 3 is 4, plus 5 is 9, plus 7 is 16. Okay, but now we have a formula for it. So that's what that is. Now, where that formula comes from, if you look down below here, it says S sub n is the mean of the first and nth terms multiplied by the number of terms. This right here is the average or the mean. Okay, so you're taking the first term and the last term, averaging them or finding the mean of them. That means the same thing. And then taking that average or that mean times the number of terms in the sequence or in the series. Okay, all right, now let's look at some of the examples here. Tell whether the sequence is arithmetic. You can tell here they did it very methodical here on part A. I always just kind of say, okay, to get from one to the other, I added 9. I added 9. I added 9. Yep, it is arithmetic, and my D would be a 9. Okay, to do the next one, I just kind of come up here and go, okay, the difference between 2 and 4 is 2. I have to add 2. Uh-oh, here I have to add 3. Uh-oh, here I have to add 4. Here I have to add 5. No, it is not an arithmetic sequence. Okay, remember, in an arithmetic sequence, D is constant. Okay, so same thing here on our exercises. Tell whether the sequence is arithmetic. So I'm going to go through here, and to get from 12 to 7, I subtracted 5. To get from 7 to 2, I subtracted 5. To get from 2 to -3, I subtracted 5. -3 to -8, I subtracted 5. So yes, it's arithmetic, and my D would be a -5. Okay, number 2. Again, here we are adding 4. Uh-oh, here we are adding 8. Okay, here we are adding 6. That's kind of all over the place. So that's a big fat no. All right, the one below here. Here we are adding 1, adding 2. Right off the bat, I can stop. Okay, not constant. The first one was a difference of 1. The second one was a difference of 2. I don't need to keep going. It's just going to be a no. Okay, and 4, number 4 here. Again, this is a +4, +4, +4, +4. So of course that's a yes. And then my D is 4. Okay, backside. Now, writing a rule. We're going to use that formula that we had on the front page. Okay, write a rule for the nth term of the sequence, 2, 11, 20, 29, 38, blah, blah, blah. Then find a to the 15th. So first thing you got to do is find the D. Okay, so to find the D, again, we're adding 9, blah, blah, blah. So my D is 9. Okay, then again, you are using this formula. This is the formula from the front side. Notice they put in a 9 for the D. Your first term, remember this is first term. Your first term in the sequence was a 2. So 2 plus n minus 1 times 9. Again, this 9 has to be distributed. Okay, so this is 9n minus 9. Well, +2 and a -9 give you the -7 plus 9n. Okay, so then you use this rule to find the a to the 15th. Notice this rule gets applied right here. Okay, so it's -7 plus 9 times 15, you get 128. Now I have seen these again and again and again. I mentioned this in 7-1, but I see stuff like this on the ACT test quite a bit. Okay, so let's look at these exercises down here for us to do. So write a rule for the nth term of the sequence, then find a sub 15. So again, let's find our common difference here. This is +4, +4, +4. I think we're good here. D is going to equal 4. Okay, so let me do number 5 over here. Make sure I have enough room here. So my a sub n is going to be, I'm using this formula right up here. Okay, so a sub n equals a sub 1, your first term, that's the 19, plus n minus 1 times my d is 4. Okay, again, if I distribute that 4, I get 4n minus 4. So this is 15 plus 4n, or 4n plus 15 is how I usually write it. I'm trying to do it the same way as the book, but I'm probably going to screw that up. So a sub n, here's my rule. Now, if I want to find a to the a sub 15, or the 15th term of the sequence, then I just put in 15 plus 4 times 15. And that is going to give me, well, 4 times 15 is 60, plus 15 is 75. Okay, let's do 6. So 6, what's my difference here? So it looks like I'm +2, +2, +2. So of course my D is a +2. And let me go ahead, and this is my a sub 1. I should have marked that on the last one. 19 was my a sub 1, your first term. Okay, that's what you need to know. First term and your D, your difference. So this is number 6. Whoop. So my a sub n is going to be the first term, the 5, plus n minus 1 times my difference of 2. Again, that has to be distributed. So this is going to equal 5 minus 2 is 3 plus 2n. So that's my rule. And then to find the 15th term, I do 3 plus 2 times 15, which would of course be 33. Okay. All right, let's do 7. I'll do it over here on the other side. 7, my D is going to be negative because I am actually subtracting 1 to get from one term to the next. So now my D is a -1. And again, this 4 is my a sub 1. That's my first term. So that means that a sub n is going to be 4 plus n minus 1 times -1. And again, that -1 gets distributed. Okay, so a -1 times a -1 is a +1. So that's going to give me 5 minus n. So here's my rule. Okay, -n plus 5 or 5 minus n. And then if I want the 15th term, a sub 15 is 5 minus 15 or -10. And again, this was number 7. I should have labeled that. Okay. Okay, now the sum. Now we're going to use that sum formula that we learned at the bottom of the vocab box here. Okay. So it says find the sum of the first 50 terms of the arithmetic series. And again, seen this time and time again on standardized tests. So first thing you got to do is you have to be able to find, you have to know the first term and you have to know the last term. If we're trying to find the sum of the first 50 terms, I need to find the 50th term. Okay, I need to find a sub 50. So first they wrote a rule here so they could find a sub 50. So of course you can tell that your D is going to be +3, right? So then they use the formula here. They substitute in the 3 for the D, find the rule. So a sub n equals 3n. So that means a sub 50 equals 150. So then according to our formula, if you remember the formula, let me write it back over here. S sub n equals n times A1 plus AN divided by 2. You're averaging or finding the mean of the first and last term and then multiplying it by the number of terms. So the first term, again, remember this 3 was our A sub 1. So this is your A sub 1, this is your A sub 50. So 3 plus 150 divided by 2, and then take all of that times 50. Okay? So let's do these together. Last two here on the study guide. So find the sum of the first n terms of the arithmetic series. So first of all, let's find our D. Okay? This, we're just adding 1, you can tell. So D is going to be 1. And of course, my A sub 1 is a 2. Okay? And my N is a 19. I need all of those pieces of information. Okay? So first, I need to find my rule. So my rule, A sub n equals 2 plus n minus 1 times 1, okay, which is just going to be 1 plus n. Okay, 2 minus 1 is 1, 1 plus n. That's my A sub n. So my A sub 19, okay, is going to be 1 plus 19, obviously, or 20. Now, you probably could have just looked at this and figured that out. But now my sum. So here's my sum. So my sum of the first 19 terms of this series is 19 times A1 plus A19. A1 is 2 plus A19 is 20 divided by 2. So 22 divided by 2 is 11. 19 times 11 is 209. Okay, let's do the next one. See if I can sneak it in here. This, we're adding 10 each time, right? So my D is 10, my A1 is 25, and of course my N is 50. Now, first I need to find the rule, okay? Well, the rule, A sub n, is going to be 25 plus n minus 1 times 10. Well, that's 10n minus 10. So this is 15 plus 10n. That's my rule, okay? So then my A sub 50, my 50th term of the series then is 15 plus 10 times 50. Well, 15 plus 10 times 50, 10 times 50 is 500, plus 15 is 515. I hope you can see this over the writing. So then, my summation here, my sum of the 50 terms in this series, the first 50, again, the number of terms, that's my 50, and then parentheses, A1 plus A50, so that's 25 plus 515 divided by 2, okay? You can poke that in a calculator, you can probably kind of do that in your head. 25 plus 515 is going to be 540, and then 540 times 25, because the 2 will go into 50, 25 times. Anyway, you get 13,500. Okay, so that's the study guide. Now, let's look at a few of the exercises on the practice A. Okay, again, this is not for a grade. This is just for those of you guys that want to learn some of this stuff so that maybe you're a little more prepared for standardized tests or for trig or algebra 1 or something. Not going to do all these, but a handful here and there. Tell whether the sequence is arithmetic. Explain why or why not. Well, the first one here. Remember, an arithmetic sequence has a constant difference between terms. So to get from 1 to 4, you add 3. From 4 to 7, add 3. 7 to 10, add 3. So yes, And when it says explain why or why not, I would just say D equals 3. I mean, obviously, I think that's pretty self-explanatory. Let's look at number 5. So number 5, to get from 1 to -2, we would subtract 3. To get from -2 to 3, we would add 5. So right off the bat, we're done. It is not, okay? And I would just say no constant D, maybe, if they wanted to know, explain why or why not. No constant D. We go from a -3 to a +5. The next one would be a what? Positive or -7. So all over the place. Okay, next one, write a rule for the nth term of the arithmetic sequence, then find a sub 8, or the 8th term. So first let's find D. So here we're adding 3. So my D is 3. My A1 is 7. That's the first term. Okay, that's what I need to know, first of all. So A sub n is going to be 7 plus n minus 1 times my D, which is 3. And again, that has to be distributed. So 7 minus 3 is 4 plus 3n. So that's my rule. Okay, and then A sub 8 is just 4 plus 3 times 8. So 28. Okay, I hope that's helpful. Let's do number 12, because it's a little different. They just give us the D, and here they give us the 10th term. Okay, so we kind of have to work backwards then to find the first term, okay? And you could take the 10th term and, like add 5 each time. You're doing the opposite to go the opposite direction to get to an earlier term. But let's take a look here. You can also do it algebraically. So if we're trying to solve, remember our basic formula, is A sub n equals A sub 1 plus n minus 1 times D. Okay, so my A sub n is going to be A sub 10. Okay, so I'm going to put in -60 equals A sub 1 plus 10 minus 1, which should be 9, times my D, which is -5. Okay, remember, this right here, the 10 is my n. Okay, so the 10th term of the sequence is -60. N minus 1 is going to be 9, because that's 10 minus 1, and then times the difference of -5. So this gives me -60 equals A1 minus 45. So my first term, if I add 45 and move it over, is -15. Okay, so now I can write the rule. So now the rule is A sub n equals -15 plus n minus 1 times -5. And again, that -5 has to be distributed. So we would have -15 plus 5, okay, which is -10 minus 5n. -10 minus 5n. That would be my rule. And then my 8th term, okay, 8th term, A sub 8 would be -10 minus 5 times 8, which would be -50. -5 times 8 is -40, minus 10 is -50. Okay, so you kind of had to work backwards to get back to your first term. Okay, hope that was helpful. Let's keep going. The next section, it says write a rule for the nth term of the arithmetic sequence that has the 2 given terms. So let's start off here, number 13. To get from 8 to 10, you went through the 9th term, right? Well, the difference from 27 minus 21, and then you actually, that encompassed 2 jumps, right? 8 to 9 and 9 to 10. So 6 divided by 2 is 3. That's going to be your D. Okay, 21 plus 3 would give you 24. That would be your 9th term. and then 24 plus 3 would give you your 27. That would be your 10th term. Okay, so D equals 3. Now we have to write the rule for the nth term. So that means that A sub n, oh wait, we also need to find A sub 1, right? So how would I find A sub 1 again? Kind of like I just did on number 12, kind of got to work backwards, right? So let me go ahead and write the formula then. A sub 1 plus n minus 1 D. So let's put in what we know. Okay, I'm going to use the 8th term. So the 8th term is 21. If I'm talking about the 8th term, then 8 minus 1 is 7. And my D then is 3. Well, that's kind of nice. This is just going to give me 21. So A1 equals 0. Okay, 7 times 3 is 21. So A1 has to equal 0. So now the rule is A sub n equals 0 plus n minus 1 times 3. So that is just negative 3 plus 3n, or 3n minus 3. I don't really care. I'm kind of impressed that I keep writing these the same way the book does, because I usually don't. So that was number 13. Okay, let me label it. Okay. Number 16. Okay. I should probably pick a different one, but I like it because it kind of starts anyway. So from 7 down to the 2nd term, we have the 7th term and the 2nd term, so that's 5 away, right? So to find the D, it's going to be 50 minus 25 divided by 5. So that means 5 equals D. Okay. Now, we also know then that if 5 is D, what is my first term going to be? Okay, my first term, if I subtract 5 from 25, I'm going to get 20, right? So I know, oh, I should have used a different color. Let me write over this so they don't all bleed together. So 5 equals D. Okay. So I also know that A1 is going to have to be 20, right? So the nth term is going to be 20 plus n minus 1 times 5. Well, again, you have to distribute the 5, okay? So if you distribute the 5, that's 5n minus 5. This gives you 15 plus 5n. That's number 16. 15 plus 5n. Sorry, it's kind of messy. Number 19, let's look at it. Find the sum of the arithmetic series. Again, we are looking at that formula that towards the bottom of our vocab box on our study guide. Okay, so this goes from 1 to 4. So in my formula, I'm looking for sum of 4 terms. Okay, so the first term, so A1 is going to be 2 because it's 1 plus 1. And A sub 4 is going to be 4 plus 1, or 5. So my formula says that the sum of 4 terms is going to be 4 times A1 plus A4 divided by 2. So 2 plus 5 is 7. The 2 goes into the 4 twice, so we're looking at 14. Okay, I hope that helps. Now let's jump over to 24, where we have a little more space here. 24, I like this one because we're not starting at a 1, we're starting at a 16, but we're going to act like it's the first. So from the 16th term to the 20th term, that is actually 5 terms. Okay, and we're going to pretend that the 16th term is in fact our first one, because that's where we're starting anyway. So we're just going to pretend that that's going to be like A sub 1. Okay, so A well, let me do a sub 16 is going to be 5 minus 16, which is negative 11. A sub 20 is going to be 5 minus 20, right, which is negative 15. So we're going to kind of pretend that this is like our a sub 1 and this is like our a sub 5. Okay, so then our formula, sum of those 5 terms is going to be 5 times negative 11 plus negative 15 all over 2, and then take that times 5 and you get negative 65. Gonna run out of room there. Negative 65. Okay. Now write a rule for the nth term of the sequence whose graph is shown. Okay. Don't let this fool you. Okay. The sequence, I'm just going to write it up above. The sequence here is 7, 5, 3, 1, negative 1. Remember your x terms, these terms are just the number of term it is. So a sub 1 is 7. So that's what this means. A sub 1 is 7. This means a sub 2 is 5. This means a sub 3 is 3. That's what that means. Okay. So what's my d here? My d is a negative 2. I'm obviously subtracting 2 to get from one term to the next. Okay. So write a rule for the nth term. So a sub n equals 7 is my first term plus n minus 1 times negative 2. Again, the negative 2 has to be distributed. 7 plus 2 is 9. 9 minus 2n. Okay, that's what you're doing there. Okay, let's look down at some of these word problems and then we'll call it good. Weightlifting, you're trying to find the maximum weight you can lift in a weightlifting exercise. You start with a single lift of 125 pounds. Right off the bat, the thing that jumps out at me, first lift, a sub 1, 125. Then you increase your weight by 2 pounds and try again. So if you're increasing by 2 pounds each time, then what do you think your D is going to be? D is going to be 2. Okay, I got that just from what they were saying there. Single lift, first one was 125 pounds. You increase by 2 each time, so that's a positive 2. You repeat this procedure until you reach a weight that you are unable to lift. So write a rule for the total weight of your nth lifting attempt. So again, going to use the formula. Okay, a sub n equals 125 plus n minus 1 times 2. Well, that's going to give me 123 plus 2n. Okay, that's my a sub n. Okay, now, part B, you are unable to lift the weight on your 6th lift. So based on your 5th lift, what is the maximum amount of weight you can lift in this exercise? So while we're solving for, and I'm just going to leave this here, you're actually solving for a sub 5. So just use the formula we found in part A. Okay, and then part C, find the sum of the weights lifted in your 5 successful lifts. So you're solving for the sum of 5 lifts. I'll let you finish it, but your first lift was 125. You're going to have to add to that your a sub 5. When you find that, it's going to go in here. Okay, and then you solve. Okay. So you need to solve those two. All right. Okay, guys, I hope that has helped. That is your section 7.2 for Algebra 2. And again, this is voluntary. Okay. Have a good one. Miss you guys.